Hi all, this is Mr. Yeager. I'm looking just to help out clarifying basically some force problems where kinematics comes back in. We cannot forget that kinematics can still be involved even in forces. And so I want to try to clear it up a little bit in terms of making it a little bit more understandable of how to approach this. So what I want to do first, I have a problem set up here, okay? But where does kinematics, basically how does kinematics connect with force, okay? If we look at it, I mean, if we list some of the kinematic equations, we have final velocity equals initial velocity plus AT, acceleration time. We have distance equals VIT plus 1/2 AT squared. And we have VF squared equals VI squared plus 2AT. These are our three primary kinematic equations. I know there's another one, but there's a reason I'm not including that one. The only new formula for force is F equals MA, Newton's second law. Basically, it technically should say net, F net equals MA, but we're going to kind of forego that for these particular problems. We're not going to worry about that much. So if I look at these two sides, what is the only quantity, the only variable that shows up in both kinematics and in force? That would be acceleration. The connecting factor between the two is acceleration, all right? And so when we do these problems, we're going to be given information to first find acceleration and then find the other quantity that's actually being asked for in the problem itself. It's acceleration that connects the two, so we have to continue using the old formulas. No unit in physics ever stands alone, so we got to continue being able to understand that these other formulas might be involved. Okay, so let's go ahead and try to solve this problem. Okay, so I'm going to do it this way because I'm worried that I'm going to delete my problem at the top here, so I just created it. All right, so if I have this problem up above, all right, if I have this problem up above, a 10-kilogram object starts at rest after a force of 100 newtons is applied for 5 seconds. What would be the final velocity of the object? Okay, so what's given to me? I have mass. Mass is 10 kilograms. I have it starts at rest, so VI is 0 meters per second. I'm given force. I'm basically listing everything as it's given to me in the problem, 100 newtons. And it says it's being applied for 5 seconds. Time is 5 seconds. It's asking what would be the final velocity. So since I'm looking for velocity, I have to use a kinematic equation eventually to help me solve the problem. Okay? And if I look at my problem, let me set this up differently. Let me go and set it up from a kinematic variables versus force variables. So that my kinematic variables would be VI equals 0 meters per second. My time is 5 seconds, and I'm solving for final velocity. So as we learned in kinematics, I can't solve this right now. I only have 2 variables. I need a third variable to help me solve this problem. Force, there's only 3 variables that we ever have in force, F, M, and A. Those are the only 3 variables that will be basically involved in the majority of force. We're going to introduce one other term, okay, but a little bit later on. So what is given to me here? I know the force is 100 newtons. I know the mass is 10 kilograms. If I know the force and the mass, can I solve for acceleration? Of course. All right. This would be F equals MA. So if I do it right underneath, 100 equals 10 times A, divided by 10, A equals 10 meters per second squared. Ta-da! So we now have the acceleration. What am I going to use that for? I can bring that on over to the other side here. I can bring it on over to the kinematic part to use it to find final velocity. What equation can I now use? Well, this is the only equation that has all 3 variables that I have and has the variable I'm looking for. So if I look at this particular equation, get rid of this arrow, it would just be VF equals 0 plus 10 times 5. I would be going 50 meters per second. Okay. So that is our connection between the two. Is the idea that acceleration connects our kinematic equations to our force equations. All right. So let's do one more problem. Because what if it goes the opposite way? Oh no. Okay. So in this one, I'm given the mass. I'm going to go ahead and do like force versus kinematics. Mass would be under force, 5 kilograms. starts at rest. That's my initial velocity, 0 meters per second. A force is applied, making the object move 100 meters, d equals 100 meters, in 5 seconds, t 5 seconds. Okay? How much force is applied? So I'm looking for force. I only have one equation for force, F equals ma. I need m and a. I need to know what a is. Well, I can't solve it with that equation. That's the only equation I have on force side. So what about the kinematic side? Do I have an equation that can help me solve for a? I do. That would be, in this case, d equals VIT plus 1/2 AT squared. So in this one, it would be 100 equals 0, VIT is 0, plus 1/2 A times 5 squared. Okay? And so this would be 100 equals 1/2 times A times 25. This would be 100 equals 12.5 A. And so this would be A equals 8 meters per second squared. So now I know what the acceleration is, 8 meters per second squared. So force would just be 5 times 8 equals 40 newtons. All right. Always trying to make sure that we keep it as simple as possible, but you have to remember to use the appropriate equations. I mean, we cannot ever think a unit in physics is alone. Okay. So I think that's basically it. Thank you.